Okay, in this video, we are going to cover how to find an outlier in a data set, or more specifically, how to determine whether there is an outlier in the data set. So recall, an outlier is a value that is far removed from the rest of the data set. It is a value that's typically very unlikely to occur, and in most cases, outliers occur due to extraordinary circumstances. So they're either really small numbers on the left side of the number line that are far removed from the rest of the data set, or they're very large numbers on the right side of the number line that are very far removed from the data set. So I've written out some steps here to help guide us into the process of finding if there are outliers in a data set. Our first step will be to find quartile 1 and quartile 3, which we're going to practice doing out by hand. We are then going to calculate the IQR. Recall that's the interquartile range, and that is the subtraction of Q3 minus Q1. We are then going to find what I call the magic number, which will be calculated by multiplying 1.5 times the IQR. That 1.5 is standard and it never changes, so you do not need to worry about where the 1.5 came from. You just need to know that that is the number that we always use. And then once we have that magic number, we will then proceed to find our lower and upper limits of what we call the normal range for the data values. Okay, so if we take the quartile 1 that we calculated in step 1 and subtract this magic number, we will find the smallest number that is still considered normal. Anything that falls below or less than this number would be an outlier. And to find the upper limit, we would take the quartile 3 that we found in step 1, add the magic number, and that will provide us with the largest number that is still considered normal. Any data values in the set that are larger than this upper limit would be an outlier. Okay, so I've put an example data set here. I actually copied and pasted it from a Hawk's homework. Please note, I'm only in Excel for recording purposes. I am not trying to show you how to use Excel or encourage you to use Excel, as we are using our Guru in this class. But there are still some glitches between our Guru and Hawk's, and Q1 and Q3 are some of those mismatched answers that do not always work out. And it's because there actually is two ways to calculate quartile 1 and quartile 3, an inclusive method and an exclusive method. Hawk's uses one of them, the exclusive method, and our Guru uses the other. And in very certain circumstances, not all, the values or the answers do not match, which can be very frustrating. So I do want to make sure we know how to do this out by hand, so that we can ensure we are entering the correct values. Now, if you are using our Guru for the 5-number summary, including Q1 and Q3, and subsequently your interquartile range, IQR, know that on the homework, you'll have to work through getting through the homework, but on exams, if you enter the correct value for Q1 or Q3 or interquartile range that matches our Guru, but doesn't match Hawk's, when I manually grade your exams, I will go back and I will fix that for you. I will give you full credit. So if you do prefer to just stick with our Guru, even though Hawk's keeps telling you you're wrong, please know that you're not necessarily wrong. It's just calculating it in a different way. Both are acceptable methods in statistics. Okay, so here's a data set that I have. And I have 14 data values. When we have an even data set, we do expect that the median will be an average of the two middle numbers. So in order to find Q1 and Q3, we first have to identify the middle of the data set. So in order to do that, you're essentially crossing off data values. So if I was doing this on paper and I highlighted data values, pairing them off, one on one side, one on the other, this is exactly how you would go about finding your median, your middle number. Please note that you have to order the data set from smallest to largest first before you can find the actual middle. If the data set was not ordered, then everybody's answer would be different. Okay, so now I can see that I have two middle numbers. A median is never two numbers, it's always one. When you have two middles, that's when you have to take an average. So our median would be equal to 26 plus 29, and then we would divide by 2. We are taking an average of the two middle numbers. So if we did this, and again, I'm purposely not entering this as a formula in Excel because I am not trying to make this an Excel video. I am going to put this in my calculator. 26 plus 29, divide by 2. My median is 27.5. Okay, so the median is actually in between 26 and 29. It is not using one or the other, meaning that 26 is not being used for the median, 29 is not being used for the median, and therefore those numbers will be included in the calculations for Q1 and Q3. If this was an odd data set and the middle value was the median number, you would exclude that number when calculating Q1 and Q3. I will do an example of that quickly after we finish this one. So we have now determined our middle is between 26 and 29. So let me divide that up so we can see that clearly division. This is the top half or the lower half, lower meaning less, smaller numbers on the number line. And here is our other half of the data set, which would be the larger numbers in the data set. We now need to find the median for each of these halves. That's how we find Q1 and Q3. So if again, I cross off pairing top of the first half to the bottom until I find my middle. This time my middle is actually a data value. Okay, so this is Q1. And I do the same thing for this bottom half. And I see that the middle number is an actual data value. There's not two of them, so I don't need to take an average. And my Q3 is 33. Okay, so I have Q1 and Q3 now. In Hawks and our guru would actually match with answers because it has to do with whether you have a data value in the center here that needs to be included or excluded. And here there wasn't a data value that was used for the median, it was an average instead. So now let's calculate my IQR. So my IQR, recall, is taking Q3, which is 33, and subtracting Q1, which is 15. And this gives me 18 as my IQR. Next up, we want to calculate our magic number. So we are going to multiply 1.5 times 18. Okay, so we enter this into our calculator, 1.5 times 18, and I get 27. So my magic number is 27. That is what I need to subtract from Q1 to get the lower limit and add to Q3 to get the upper limit. So let's do that now. My lower limit is going to be found by taking Q1, which is 15, and subtracting the magic number of 27. And this is going to give us a lower limit, or the smallest number that is still considered normal. Okay, that happens to come out to a -12. So what this -12 is saying is that if there are data values in this data set where they are smaller than -12, they would be considered outliers. I look here in my minimum data value, my smallest data value in the data set is a 9. So I do not have any outliers on the left side of the number line or on the smaller numbers. Let's now find our upper limit. So I'm going to take Q3, which is 33, and add the magic number of 27. And that's going to give me 60. So 60 is the largest number that is in referencing to this data set that is still considered normal. So I take a look at my maximum value, it's 53. I see that I do not have any values in this data set that exceed 60, and therefore I do not have any outliers that are on the right side of the number line, or very large numbers. So in Hawks, if it was asking me, are there any outliers in this data set? My answer would be no, there are no outliers because I have no data values that are less than -12, and I have no data values that are greater than 60. Let's just quickly look at how the calculations change if I was to have an odd data set. So let me clear out all of this highlighting business here. Oops. No borders. And let's delete this stuff. Okay. Let me just delete this last data value. Bloop. Now I have 13 data values in the data set. I just want to show you the difference doing IQR or Q1 and Q3 out by hand if we had an odd data set. So again, we would find our median first by crossing off top and bottom, pairing off the numbers. Pairing away, and you can pair more than one. So I can do 2 here, making sure that there's 2 here. Oh, I can do another 1. And this time I have an actual data value. Whoops, changed the color too soon. I have an actual data value that is in the center. So my median for an odd data set is actually one of the data values in the set. Now for Hawks, they want you to ignore the 26 and use 9 through 19 to find Q1 and 29 through 52 to find Q3. In our Guru, they use the inclusive method and they include 26 in the top half and they include 26 in the bottom half. And that's why the answers can come out different. So if I was to cross off, I would see that I have 2 middle numbers for Q1 if I'm using the Hawks method of excluding the 26. And I would calculate Q1 by averaging 13 and 15, which would give me a Q1 of 14. Again, I got that by adding 13 plus 15 divided by 2. Same thing would happen down here if I'm excluding the 26 in my Q3 calculation. That will leave me with 2 data values to average. When I average these 32 plus 33 and divide by 2, I get 32.5, and that would be my Q3. Okay, so to sum this up, what we covered was how to find quartile 1 and quartile 3 out by hand, and how to find out if a data set has an outlier.